we've done inverse trig functions before. We did them in right angle trigonometry. We've done them in our algebra classes. So anytime you're doing inverse trig functions, you're actually solving for the angle. So up until this point, like with the unit circle, I've asked for like sine or cosine or whatever of a specific theta. So I've said, what is the sine of pi over 2? And you would say, well, that's 1, all right? What is the sine of pi? Oh, that's 0. And so what I've been giving you is the angle, and I've been asking for the trig function, all right? With arc sines or inverse trig functions, you are given the trig equation or the trig number, and you are asking for the angle. So you have the trig ratio, and you're asking for the angle. Think of it in right angle trigonometry when you were given two sides and you're asked for the angle that makes it. Well, you look at what two sides you have. I have opposite and adjacent, so I'm going to use the inverse tangent, all right? And so you are solving for the angle. You're solving for the angle. But now we're going to shift from our right angle trigonometry that we've done with like word problems, and we're going to move to unit circle. So if I were to then give you a sine, like 1/2, you would then tell me what angle gives you that sine. All right? So think of your unit circle, and if you have it, you can get it out. But your unit circle, and what you're going to be looking for is, I am giving you a sine, cosine, or tangent, and you are telling me what angle gives it to you. Now, the first thing you have to recognize is that it is a circle. So if you look on your unit circle and I say 1/2, you will see 1/2 appear more than one time in your y value, right? You'll see it appear twice. You'll see a positive 1/2 twice and a negative 1/2 twice. And so because of that, they've put some limitations on these inverse trigs. Now, if they don't tell you otherwise, you're going to assume this limitation. Sometimes they'll say, where does it occur on the entire graph? And then you have to basically indicate that it's repetitive. But if they don't, then you are going to assume these particular restrictions that they are telling you right here. So the first thing we're going to look at is the sine value. So you've noticed that they have restricted the inverse sine to the first and the fourth quadrant. First and fourth quadrant. So this is where we're looking at the domain or the restrictions on the sine. This is why they've done that. Because if I go in the first quadrant, my sine is always positive, right? If I go in the second quadrant, my sine is also positive. And so if I were to do the first two quadrants, I wouldn't hit any of my negative signs, all right? But then if I did it this way, I would have to do a main that kind of jumps over a quadrant. So instead of doing that, they did the first quadrant, your sine is positive, and they did the fourth quadrant, your sine is negative. And this will cover every sine value on the entire unit circle, because the sine values over here in the second quadrant just mirror the sine values in the first quadrant, and the sine values in the third quadrant just mirror the sine values in the fourth. So if you take the first and fourth, you have covered all of your sine values, all right? And so that's why they restrict it to the first and fourth. So let's look at the examples here. This is the notation. There's two ways. You will see it written as sine to the -1, just like this. That means I want the angle that gives you that sine. You will see it as arc sine. So this notation here, arc sine. That means I want the angle, the theta, that gives you this particular sine, -square root of 2 over 2. All right? And so let's look at this one, example 1 on page 281. All right, so for this first one, I have a positive sign. So I am only going to look in the first quadrant. So in the first quadrant, if I look at my unit circle, where will I find a sine of 1/2? Yeah, so if you look at pi over 6, you will see a positive 1/2 as your y value, your sine. So the answer to this particular problem here would be pi over 6. This is why they restrict it, because look at your second quadrant. You have a 1/2 in your second quadrant. If they didn't restrict it, you would have to tell every single one of them. And sometimes they want you to. Sometimes they'll give you that range. But if they don't, you assume first or fourth quadrant. Now I want you to notice the second one. Is it positive or negative? Negative. So which quadrant am I going to look in for sine? Between the first and the fourth quadrant for sine. Third, but we don't consider third for inverse tangent, so it has to be which one? Fourth. Between first and fourth, it has to be in the fourth. Now, look at this particular one in the book. your unit circle, it shows 7 pi over 4. You'll notice here they have negative pi over 4 because the range for this, so instead of doing from 0 to pi over 2 and then jumping second and third and then going 3 pi over 2 to 2 pi, right, for your range here, what they're actually going to tell you to do is do a range of negative pi over 2 to pi over 2. So instead of using what it would be in positive, you would just say I'm going to use from 0 to pi over 2 in the first quadrant and 0 to negative pi over 2 in the fourth quadrant. Okay, does that make sense? And so in your book, a lot of times it will then do it in negative. So if I were just going to start at 0 and go down, they're going to do it as a negative pi over 4, which is why they do negative pi over 4. Because in the range values, they want you to go from negative pi over 2 to positive pi over 2, all right? If they gave you a different range, some problems will say, hey, from 0 to 2 pi, what gives you this sign value? And then you're going to find all the ones that give you that value, and you would use your positive. But if not, you're going to assume negative pi over 2 to positive pi over 2, and you're just going to use your negative values. All right, let's look at the third one. Sine to the negative 1 of 3. What angle measure gives you a sine value of 3? So for this one, because your values of sine are not bigger than 1 or smaller than negative 1, this is not possible. So this is invalid, and we do not actually have one. It does not exist. So this particular one, you have no angle that will give you a sine value of 3. It's not possible. So try guided practice 1. For this first one, you should have gotten pi over 3. Negative 2 pi, that is definitely bigger than 1. You should have said not possible or empty set there. And then negative 1, that is possible, negative pi over 2. In the positive world, that's 3 pi over 2. But from negative pi over 2 to pi over 2, that is your answer. All right, so for cosine, for sine, we actually did just the first and fourth quadrant. And so they actually mentioned that 5 pi over 6 is also 1/2 for our first one that we did up there. But they didn't name that. And the reason they have limited it is because they want you to know exactly which one you're giving them. So sine limits you to this right side of your graph. If you look at cosine, it limits you to the top half. Why does it do this? Well, I have all positive signs in my first quadrant. I have all negative signs in my second quadrant. So if you're looking for your range here for sine, your input values here, the range here is going to be restricted to 0 to pi. So your inverse cosine, now your range is going to be 0 to pi. All right, and so just like sine was restricted, and they didn't give us the second option when we did sine of our arc sine of 1/2, when you do arc cosine, you're just going to look at your positive options in first quadrant, negative options in second quadrant. So let's look at the first one. And so none of these will have negative angles because we're literally just going from 0 to pi. They'll all be your positive ones, all right? Look at the first one. Is it positive or negative? Negative. So which quadrant am I going to be in? The second quadrant. Which angle gives me a negative square root of 2 over 2 for my cosine?
3 pi over 4.
Yes, 3 pi over 4. Everybody see that on your unit circle. 3 pi over 4. Look at the middle one. Arc cosine of negative 2. Arc cosine of negative 2. What's the problem?
It's too high.
It's too low or too high, right? It's too, absolute value is bigger than 1. Doesn't exist, all right? And the inverse cosine of 0. What gives you, okay, don't put in the angle 0. What gives you a cosine of 0 between 0 and pi? Pi over 2. All right, so we have a tendency for that one to give me what the cosine is at 0, at angle 0. That's not what you're looking for. The angle pi over 2 gives you a cosine of 0. All right, so try guided practice 2. The inverse cosine of negative square root of 3 over 2. Should have gotten 5 pi over 6. 5 pi over 6. Arc cosine of 2.5 is not possible. The inverse cosine of negative 1/2 is 2 pi over 3. 2 pi over 3.
For cosine.
So for tangent, you'll notice it has the same restrictions as sine. All right? There's a reason for this because your tangent is going to be positive and negative in the first and second quadrant as in the first and fourth quadrant. So really they could have used either one. I really think they did it because tangent is sine over cosine. I feel like you'd hit all of your tangent functions here, whichever quadrant you did it in, but they limited it the same as sine, all right? The same as sine. You're gonna get all your positive tangents in the first quadrant, any negative tangents in the fourth quadrant. So tangent's gonna be the same as sine. Look at tangent, it's a little bit more difficult to see because on your unit circle, you have your sine and cosine, it's right there. But in order to know your tangent, you have to put the sine over the cosine, all right? And so if you look at the inverse tangent of square root of 3, you're not going to find the square root of 3 on your unit circle. It's going to be in a fraction, but you're not going to find it alone, all right? So you have to start recognizing these things. How would I get the square root of 3 dividing a sine by a cosine? Well, the square root of 3 would likely need to be on top, all right? So look at your pi over 3 on your unit circle. So look at your unit circle like I have up here and look at your pi over 3. And we're going to do this one together. All right, so I have pi over 3 here. My tangent is sine over cosine. Over x, okay, y over x. So if I put square root of 3 over 2, that's my y value, over my x value, 1/2. How do I simplify that? A fraction divided by a fraction. So I say square root of 3 over 2, change it to multiplication. 2 over 1, what am I going to get? Square root of 3. And so that is why my pi over 3 is going to give me a square root of 3 tangent, all right? What happens if I look at a pi over 6, all right, where it's reversed? Pi over 6 on your unit circle, tangent of pi over 6, all right? So on your unit circle, pi over 6, your y value now is 1/2, and your x value is square root of 3 over 2. If I flip that one, I'm going to get 1 over the square root of 3. That's not how you're ever going to see it. How are you going to see it? What do I need to do?
You have to make it to the top.
Yeah, I need to rationalize it. So square root of 3, square root of 3.
Square root of 3 over 3.
Yep, and that's what you're going to see for all of your pi over 6s, okay? So for your pi over 3s, your tangent is going to be the square root of 3. For your pi over 6s, your tangent is going to be your square root of 3 over 3. What about your pi over 4s? What's your x and y value of your pi over 4s? It's the same thing, right?
2 over 2 is square.
So what happens when I put a number over itself? What's your tangent going to be there? It's going to be a 1 or a negative 1, depending on what quadrant you're in. Okay, so once you start to recognize those three, then you'll figure out where you are on it. All right, let's look at arctangent of 0. Arctangent of 0. All right, so I have this right here. Arctangent is 0. My tangent is 0 when my sine is 0, okay? So in the first and fourth quadrant, my sine is 0 at 0, okay? If I had an undefined one, tangent is undefined where my x is 0, okay? Where my x is 0, that's at the top and the bottom. But if my tangent is 0, it's wherever my sine is 0. That's where it's going to be tangent of 0. So for this one, your answer would just be 0.
So, does it matter if we're...
So for negative square root of 3 over 3, you should have gotten negative pi over 6. And for negative 1, you should have gotten negative pi over 4. Negative pi over 4.
You just change it to a negative.
At least we're not graphing.
All right, the angle or the arc between negative pi over 2 and pi over 2 with the sine of x. So sine and tangent say the same thing right there. Negative pi over 2 to positive pi over 2. The symbols, you can see it's to the negative 1. If it is written out, it will say arc sine, all right? The inverse function will show a negative 1, or it will say arc and the function. The domain for both sine and cosine is negative 1 to positive 1. You can see that tangent doesn't have restrictions there because it is literally one side over the other. And so they can be larger or smaller than one. And then the range for the only difference is cosine is from 0 to pi. So first and second quadrant versus first and fourth. All right, that's just a summary for one. Let's look at compositions. This seems, remember composition functions? If you take a function and its inverse and do a composite, you'll always get x, right? Do you remember that? In fact, that's how you verify it. If you have two functions and you're trying to see if they are inverses of each other, you do the composite and you should get x. If you get anything other than x, they're not inverses of each other. We did that in Precal, all right? I mean in Algebra 2 and at the beginning when we did the chapter 0 for Precal. Yep, the prerequisite chapter, okay? So this is nothing new. So if I take the sine then, that's the function, of the inverse sine, that's the inverse of that function, I should get x, or I should get whatever is in here, all right? So if I'm taking the inverse sine of square root of 2 over 2, and I get that angle, then the sine of that angle should be square root of 2 over 2. That's just how it works. Let's look at the example. All right? So the first one that they give us is negative 1/4, the inverse of negative 1/4. All right? The first thing we're going to check is, can I take the inverse sine of negative 1/4? Does it fall in my range? So remember, my range of sine goes from negative 1 to positive 1. So what I need to find out is negative 1/4 in that interval? And the answer is yes, all right? So it's possible to take the sine inverse of negative 1/4. It falls in the range. So I am going to get some angle here. I don't know what it is, but then I'm going to take the sine and I should get negative 1/4. Let's do one that we know, all right? Let's do one that we know. Let's say I have the sine inverse of square root of 2 over 2, and I want to take the sine of that inverse, all right? So we're going to work the inside out. What angle gives me a sine value of square root of 2 over 2? Look at your unit circle. A 45, or a pi over 4, right? So this inside part would be pi over 4. What's the sine of pi over 4? It's not a trick question. The y value of pi over 4. The sine value of pi over 4. Square root of 2 over 2. All right, yes. So that's what they are telling you. They are saying if what's inside is within your range, then taking the inverse of the trig function will just yield what was on the inside. So that's what we did for this one. So for this one up here, yes, negative 1/4 falls in the range correctly. So if I do the sine of the inverse sine, I will just get what's inside there, which is just negative 1/4. It will work. All right. So far, so good. All right, this is the other. So this is the arctangent. So this is like tangent negative 1 on the outside and tangent on the inside. I cannot jump straight to the fact that I think it's going to be pi over 2. Pi over 2. The first thing I have to do is say, is there a tangent of pi over 2? So pi over 2, is there a tangent? What's your tangent at pi over 2? Y over x. Y over x. What's the tangent of pi over 2?
1 over 0.
It's 1 over 0. What's the problem?
It can't.
So if this inside part does not exist, I can't do any of it. So for this one, I wouldn't just put down, oh, it must be pi over 2 because it's an inverse of a function. I would say, nope, does not exist. Empty set, does not exist.
Wait, because pi over 2.
Because if I do, so here's what I'm trying to do. I know 7 pi over 4 is going to work. All right, but if I did 7 pi over 4, I'm going all the way around outside of my boundaries. It wants me to go from 0 to pi over 2 and 0 to negative pi over 2. So I know that this is going to work. Yes, 7 pi over 4 is a valid answer, except I have to write it within my range. And so I have to write it as what happens, I'm going to go down pi over 4, negative pi over 4. It's the same angle, but you have to write it in terms of what it understands. All right, so try those 3. All right. The tangent of the arctangent of pi over 3 is pi over 3. That's in your range, and it is in the range of inverse tangent. All right, the cosine of 3 pi, the inverse cosine of the cosine of 3 pi over 4 is 3 pi over 4, also in there. And the arc sine of the sine of 2 pi over 3 is pi over 3. Pi over 3. You have to stay within your first and fourth quadrants there.